12-2, multiplying rational expressions. So in this lesson, you learn to multiply rational expressions. Why is it important? Because you can use rational expressions to solve problems involving traffic and money. Let's take a look at a real-world application on traffic. On the Sunday after the recent Thanksgiving, westbound traffic was backed up for 13 miles on the exit of Massachusetts Turnpike. Assume that each vehicle occupied an average of 30 feet of space in a lane and that the turnpike has 3 lanes. You can use the expression below to estimate the number of vehicles involved in the backup. So this is the expression we will use. So you have 3 lanes, multiply that by 13 miles a lane, okay? And 1 mile is 5,280 feet, okay? And one vehicle is 30 feet. And we will simplify this in example 3. Okay, so this multiplication is similar to the multiplication of rational expressions. Recall that to multiply rational numbers that are expressed as fractions, you multiply numerators and multiply denominators. You can use the same method to multiply rational expressions. From this point on, you may assume that no denominator or rational expression has a value of 0. So in 12-1, we look for excluded values. But from this point on, from this lesson onward, we will assume that no denominator or rational expression has a value of 0. Therefore, we do not need to look for the excluded values from problems starting at this point all the way to the end of the book. Okay? So you have rational numbers such as 4 times 4 over 5 times 3 over 7. To be able to solve 4 over 5 times 3 over 7, okay, what we do is we simply multiply the numerators, we multiply the denominators, and we end up with a product of 12 over 35. Okay, now in terms of a rational expression, when you have 3 over m times k over 4, what we do is simply multiply 3 times k all over m times 4. And that will give us 3k all over 4m. So let's do the same thing in example 1. And if you have two rational expressions being multiplied, 3x squared y all over 2rs times 24r squared s all over 15xy squared. Okay, method 1, we will divide the common factors after multiplying. Okay, so we have now 3 times 24 will give you 72. Okay, r squared, okay, s, x squared, and y. We simply multiplied everything, put it into one expression right there. Okay, second thing, on the denominator side, 2 times 15 will give you 30. And then we simply brought the r there, the s, okay, x, and the y squared. Okay, so what you can do here, okay, is find the GCF. Okay, so what you want to do is find the prime factors of 72, and the prime factors of 72 are 2. If you want to do the drop down method, that would help you. 2, this is 36, 2, 18, 2, 9, 3, 3. So this would be 2 times 2 times 2 times 3 times 3, okay? And then simply expand on your r squared, okay? Or if you want, we can do this. Well, let's just expand it so it'll be easier for you to follow. R times r times s times x times x times y, okay? All over. Prime factorization of 30 would be 2 times 3 times 5 times s times x times y times y. And we start canceling our common factor. That's a 1, that's a 1 right here. 2 over 2 is 1. Okay, and 3 over 3 is a 1. Okay, we have s over s is a 1 as well. And we have x over x is a 1. and y over y is a 1. Okay? And then we simplify now. We end up with 4. 2 times 2 is 4 times 3 is 12 r squared. Okay? This case would be 5, simply 5y. Okay? And the simplified form is 12 r squared. Okay? 12 r squared all over y. Oops, sorry, we forgot one r here. There is one more r here, that r over there I forgot to mention. So that cancels out. That's 1 over 1 as well. There you go. And then this will remove that little r right there. One more r. So it's simply 12r all over 5y. 12rx because that's your x. Sorry, let me make that black. Okay, 12rx all over 5y. 2 times 2 is 4 times 3 is 12. Then you have the r, you have the x, 12rx all over 5 times y. Okay, right there. Okay? So what we crossed out is simply the GCF, and that's what happened here. Your GCF will be 6rxy, and then you're left with 12rx all over 5y. Okay? So either way you do it, the only thing with finding the GCF is that you need to be able to do this mentally. In this case, there's no mental stuff here. You simply write down um, the prime factorization and completely factor each monomial, and you get your simplified form. So that's method 1. Method 2 is, okay, divide the common factors before multiplying. Okay, so we want to divide the common factors before multiplying, so we start cross-canceling right now. Okay, so if you notice, 3 goes into 15, 2 goes into 24. We start cross-canceling. Okay, let me rewrite this so we can make this. So you have 3x squared y, 2rs divided by 24 r squared s all over 15 xy squared. So we start cross-canceling before we even multiply. So 2 and 24, that's a 1, and this is a 12. 3 and 15, that's a 1, this is a 5 right here. And the r squared and the r, you cancel out that r and you cancel out that 2. Okay, the y, you cancel out the 2, you cancel out that y, and the s, cancel out both s's. So look what's left. Okay, you need to cancel out this x and that squared x. So we are now left with 12rx, and at the bottom we're left with 5y. Okay, and that's exactly what they did here. So we cancel out everything, cross-canceled everything. Okay, and you ended up with still 12rx all over 5y. Okay, so sometimes you must factor a quadratic expression before you can simplify a product of rational expressions. So let's take a look at this one. Find each product, m plus 3 all over 5m times 20m squared all over m squared plus 8m plus 15. First, copy the problem, and let's start factoring. Okay, m squared plus 8m plus 15. Okay, we can actually put them all together. So if you factor m squared plus 8m plus 15, so you have m squared plus 8m plus 15, and using the power of x, this becomes 15, and this is 8. Two factors are 3 and 5, therefore this is m plus 3 times m plus 5, right there. Okay, so if we're going to rewrite this, okay, that will be your factored form, which is m plus 3 times m plus 5. Okay, and then we start cross-canceling right here. So we start cross-canceling. Since they're all multiplication, we can cross-cancel the factors. The m plus 3 cancels out. Okay, the m cancels out. 1m cancels out here, so that you're left with the m. And you are now left with 20m all over m plus 5. And that's exactly what happens here. Okay, so the 5m, oh sorry, I forgot to cross cancel that 5. That's a 1 and this is a 4. Okay, so from there you end up with 4m, okay, 4m right there, all over m plus 5. Okay, let's take a look at the letter B. We have 3 times x plus 5 all over 4 times quantity 2x squared plus 11x plus 12 times 2x plus 3. Okay, so remember we're multiplying with 2x plus 3. The denominator is 1. So we can begin our factoring. Okay, so this becomes 3 times the quantity x plus 5 times 2x plus 3. Okay, all over 4 times 2x squared plus 11x plus 12. Okay, so we factor 2x squared plus 11x plus 12, and the factored form is for 2x plus 3 plus x plus 4. Remember, we are using the power of x, or the x method, to factor this. In this case, we're using the grouping method after we use the power of x. So basically, you have 2x squared. Let me redo that for you, just as a refresher, plus 11x plus 12. And first, we use the power of x. This is 24, and this is 11. Okay, so what are the factors of 24? That will give you 11. Okay, and that would be 3 and 8. But since the coefficient of our quadratic term is not 1, we use grouping. So we will rename 11x as 3x and 8x. So this now becomes 2x squared plus 3x plus 8x plus 12. And we group them. This becomes 2x squared plus 3x plus 8x plus 12. Okay, find the greatest monomial factor, which is x. End up with 2x plus 3. Greatest monomial factor, which is 4. This becomes 3x. Sorry, 2x. Can't do that. Oopsie. Too much. Okay, let me just erase it. This becomes 2x plus 3. And therefore, using the grouping method, this becomes x plus 4 times 2x plus 3. Exactly what we have there. Okay? So now we can start cross-canceling. We can now cross-cancel the 2x plus 3 and 2x plus 3. Okay? And we're left with simply, okay? So we cross-cancel those two. We left with 3 times x plus 5 all over 4 times x plus 4. You can actually leave it in this form, or you can distribute the 3 in the form to become 3x plus 15 and 4x plus 16. So we simplify the numerator and we simplify the denominator. Remember, an expression is in simplest form when there are no parentheses. But sometimes this will be acceptable if that's one of the choices. Okay, the secret word for this particular lesson would be softball. The secret word would be softball. Okay, and let's take a look at the last example. When you multiply fractions that involve units of measure, you can divide by the units in the same way that you divide the variables. Recall that this process is called dimensional analysis, and we discussed this in the past. So let's take a look at the beginning of the lesson and let's answer what we started with in terms of the question about the number of cars, the estimated number of cars that were backed up on the freeway. Okay, so this is what we're asked to solve. 3 lanes, 13 miles per lane, 5,280 feet per mile. One vehicle is equal to 30 feet. So we use our cross canceling method. So this lane unit cancels out with that lane unit. The mile unit cancels out with that mile unit. This feet unit cancels out with that feet. Okay, and we still continue cross canceling. Okay, we cross cancel the 5,280. Okay, we cross cancel it with, well, let's do this first. Cross cancel the 3, that's a 1, and the 30, that's a 10. Okay, and from there we can cross cancel again. The 10, that's a 1, and the 5,280, which becomes 5,528. So I think that's about it. Okay, and if you notice, if you do that, this is what happens. Okay, and you end up with multiplying 528 by 13. Okay, and the only unit left is vehicle. All the other units have been canceled out. So you're left with 13 times 528 will give you 6,864 vehicles. So the backup involved around 6,900 vehicles. You rounded to the nearest hundreds place. Okay? And that's our lesson. Thank you for watching.